Well, he expected at least the moon and perhaps the sun from his salesman. He wanted a good sales job, and he wanted a lot of orders because we grew with orders. And he also used to say, look, the salesman who is the man who makes things happen in the United States. Nothing happens until something is sold. Then it's manufactured, it's delivered, it's used, but nothing happens. And so the salesman, in his mind, was a sort of an American hero, and perhaps very high on the list of American heroes.
It was these heroes of IBM who convinced hundreds of ordinary businessmen to buy IBM's 650 computer. Orders started pouring in. Within a year, IBM had sold almost 1,000 of them and soared past Remington Rand's Univac to become the largest computer company in the world.
IBM's sudden new dominance threatened the fledgling British industry too. In the early 50s, a handful of manufacturers from Ferranti to Lyons fought over what few customers there were. At this business efficiency exhibition, the British Tabulator Company, Britain's equivalent of IBM, was showing its wares. The firm's one and only computer salesman tried to attract attention by programming it to play noughts and crosses. Later, all the major British companies would merge to take on IBM.
We can't expect to be able to outproduce a large American company, but there's no reason why we can't outthink them.
And a great deal of thought was needed back in the 50s if manufacturers on both sides of the Atlantic were to honor the promise of their advertisements. Computers, the advertising claimed, were the key to the future. But in their enthusiasm, they failed to mention one thing.
In the late 1950s, the computer manufacturers' advertisements and proposals were rosy, and we who were making those promises turned out to be liars. We didn't know we were, but we were. The problem was software development.
Writing software, the programs that tell the computer what to do, turned out to cost 2, 3, even 4 times the price of the machine itself.
In fact, this problem of software development grew so severe that it really threatened the further growth of the computer industry.
Computers costing thousands of dollars a month would sit idle while programmers struggled to talk the computer's arcane language.
We BPX to 10D, AOR 10. Well, this AOR gets us into a BSN 11. Don't we want a BSN 12 instead?
Unfortunately for programmers, computers cannot execute programs written in English. They require a special language of their own.
The computer only understands the language of binary, and it's really a code, not a language. Binary simply means zeros and ones, analogous to an electric light switch, which is either on or off. If one simply looks at an example of what the binary code would have to be for 5 times 7 plus 3, one can see that it's incredibly difficult to write that kind of thing accurately. In the first place, it's tedious to write it, and in the second place, it's almost impossible to do it correctly.
Programmers developed alphabetic codes which were easier than binary. But still, programming was difficult and tedious, and few people were attracted to it.
The shortage of programmers could, in the worst case, have caused the growth of the computer industry to come to a dead halt because there were so few programmers. Without programmers, you don't have programs, that is to say software, and without software, the computer is useless. You might just as well have an automobile without a driver. It doesn't go anywhere, it just sits there.
This crisis could only be solved by making programming easier to do. If people couldn't talk to computers in binary, perhaps computers could be made to understand a language a bit closer to normal English. The first so-called high-level language that became significantly used was Fortran. Scientists and mathematicians found it relatively easy because it allowed them to write equations in the way they were used to. Businessmen who didn't often write equations didn't find Fortran much help. They needed their own language, one that could handle letters as well as numbers and could process files of data.
For that, you needed a different kind of language, and that led to the development of COBOL, which stands for Common Business-Oriented Language. COBOL was very English-oriented. That is to say, you wrote the programs in a language which was certainly not identical to English, but at least looked like English when you read it and wrote it.
COBOL was a revelation, easy to use and to find errors. And with the help of another piece of software called a compiler, the high-level program is automatically translated back to the binary code that the computer understands.
With the programming problem solved, at least in principle, the stage was set for an endless variety of new uses for computers in all walks of life.
Operating around the clock, this communication center receives and processes all incoming requests for police service.
Computers could now track police cars or pedigree bulls.
In Kansas City, Missouri, the American Hereford Association dedicated a new electronic computer. On hand to push the starting switch, America's grand champion Hereford Bull HR Silver Image 70. This hoof switch started a new IBM 1401 computer that will keep track of all registered Herefords. Silver Image thus became the first animal ever to trace his own ancestry and appeared quite interested in the results.
But most computers were found in administrative offices where armies of clerks were beginning to disappear, replaced by a single computer. Computers also started showing up in factories, controlling machines and processes that once required hundreds of human hands. As computers intruded more and more into the workplace, fears were raised that increased automation might make millions of workers obsolete.
Automation is a young, new word, heavy with promise and with problems. As a matter of fact, several people have suggested to us that it's a little too heavy for a Sunday afternoon in June. Could be. We shall see.
And it's true that this plant will cause a layoff of some of our loyal workers. However, it's a necessity to do it to be competitive in today's industry.
Funny, I thought you'd never get back. Do you know what?
Even Hollywood took up the issue.
He's up on the roof feeding the pigeons. No. Do you know what he's doing here? What? He's trying to replace us all with a mechanical brain. He's under special assignment to Azai to see if Emmerich can be adapted to this department. That means the end of us all.
Peg, calm down. No machine can do our job.
That's what they said in payroll.
Movies like Desk Set revealed the conflicting emotions computers stirred up in society. While many people viewed them with fear and disdain, others thought they represented progress, the future, a relief from tedious tasks. Not surprisingly, the staunchest advocates for computers were the computer manufacturers, like IBM's Tom Watson Jr.
A lot of people call these machines giant brains, and whenever I hear the term, it makes me shudder, because they are giant tools. They're certainly not giant brains. And if you have good tools, you're upgrading man, not downgrading him.
That was a common argument, that computers replaced jobs nobody wanted. Certainly it was true at the Bank of America, which employed almost 2,500 bookkeepers just to process personal checking accounts. Every day, they sorted and recorded more than 9 million checks, the perfect job for a computer.
This is Los Angeles, and I'm Ronald Reagan. May I hear, please?
In 1961, in one of his lesser roles, Ronald Reagan was the commercial spokesman for General Electric, who made the bank's computer.
The Bank of America has called this new system Electronic Recording Method of Accounting, or by the more familiar and friendlier term, IRMA. A competent, experienced bookkeeper using conventional mechanical equipment is expected to do the sorting and posting for about 250 accounts an hour. IRMA can sort and post 550 accounts a minute.